In today's video, we're going to be discussing about limits of calculus 1. So let's start. Now we're going to start with the question, what are limits? So I'm going to lead with an example. Suppose you have a train and it is going towards a station. Alright, let me make this. Yeah. So a train is going towards a station. So there will be a certain distance between the train and the station. And the train will take a certain amount of time to reach the station, right? So as the time for the train to reach the station decreases, so as time decreases for the train to reach the station, the distance between the train and station will also decrease, right? Will also decrease. So therefore we can say, as time approaches 0, distance also approaches 0. Now if time, we assign the variable x and distance as f of x. What can we say? We can say that the limit, lim stands is short for limit, as x, which is time, approaches 0, of f of x equal to 0, because the limit as time approaches 0 of distance is just 0. Hence we can say this way. So limit is basically saying that a certain value, or it's saying that it tells us what a certain value is approaching as a reference, or another value approaches a certain constant. All right, say you have x which is approaching 2 and your function is x square over x. How would you evaluate this? So basically our question is the limit as x approaches 2 of x square over x equal to what? So over here we can use direct substitution and tell that this function is just 2 square over 2, which is 2. So we can say the limit as x approaches 2 of x square over x equal to 2. That's the general idea behind limits. So I'm going to tell you a couple of limit laws which are important to know. Limit laws. Okay, suppose the limit as x approaches a of h of x equal to L, and the limit as x approaches a of g of x equal to m. So if we take these two cases, so the limit as x approaches a of h of x is L, and the limit as x approaches a of g of x is m. Therefore we have a couple of rules, starting with the sum rule. The sum rule states that the limit as x approaches a of h of x plus g of x, hold on, would be equal to L plus m. Over here we can take x plus a common because both the our original equations have x plus a. So therefore the limit of this plus this equal to the answers, or this plus L plus m. Okay, our second rule is the difference rule, which I think you can tell what it is by the name. The difference rule states that the limit as x approaches a of h of x minus g of x equal to L minus m. Pretty simple. Our third rule is called the constant multiple rule. Constant multiple rule. The constant multiple rule states that the limit as x approaches a of any constant k multiplied by h of x, or wait 1 second. k multiplied by h of x equal to k times L, where L is basically the limit as x approaches a of h of x is L. So the limit as x approaches a of any constant times a function equals to the constant multiplied by the limit of the function. We can rewrite this in this way. This would be equal to k multiplied by the limit as x approaches a of h of x, which is just equal to k times L, which is what we got here too. Okay, our next law is the product law or product rule. What does this state? The product law or rule states that the limit as x approaches a of h of x times g of x would be equal to L times m. Again, pretty simple. Our next is the quotient rule. The quotient rule. What does the quotient rule state? Again, I think it can be pretty obvious by the name. The limit as x approaches a of h of x over g of x equal to L over m. And that's it. Our next rule is called the power rule. The power rule. You can pause the video and copy down these rules. So, power rule says that the limit as x approaches a of f of x raised to n equal to L raised to n, because limit as x approaches a of I shouldn't say f of x, sorry, oh yeah, h of x, my bad. H of x raised to n is just L raised to n, because the limit as x approaches a of h of x is L, and the power you just remain the same. Okay, and the seventh is known as the root rule. What is the root rule? The root rule states that the limit as x approaches a of f of x, of h of x to the nth root is equals to L to the nth root, basically. So the limit of this and the root remains the same. Okay, we can also say it in the say the root rule in this way: the limit as x approaches a of h of x raised to 1 by n equals to L raised to 1 by n, depending on what n is. And those are our seven limit laws, basic laws. Now I'm going to talk about trigonometric functions in limits. Trigonometric functions. What do these trigonometric functions say? Okay, our first one is as x approaches 0, sine x equal to x. So as x approaches 0, sine x is just equal to x. This is our first trigonometric rule or law. Second one is the limit as x approaches 0 of sine x over x is just equal to 1. This is the second trigonometric law. A third one is the limit as x approaches 0 of tan x over x is equal to 1. Is equal to 1. Our fourth one and our final one is the limit as x approaches 0 of 1 minus cos x over x, which is equals to 0. So these will be our 4 limit laws, we can say, trigonometric limit laws. So as you might recall from before, I said that the limit as x approaches 0 of sine x over x equal to 1. Why does this equal to 1? So when I explain this, you should know that there are explanations for all the trigonometric laws which I just told. All explanations like this. So if you can see that x approaches 0. So we can plug in a value, because we can't plug in 0. We can plug in a value close to 0, like zero point 0.1. So this would be equal to the limit as, no, sorry. If you plug in 0.1, we can directly write sine 0.1 over 0.1. Sine 0.1 over 0.1, when you calculate it in your calculator, is 0.998. And you can tell that 0.998 is approximately 1, or is very close to 1, or we can say it approaches 1. So therefore we can tell the limit as x approaches 0 of sine x over x is just equal to 1, because when you, even though you can't plug in 0, you can tell that this limit approaches 1. So in the end it would turn out to be 1. Alright. Okay. Our next topic is a short one, which is known as infinite limits. Alright, what do you mean by infinite limits? Alright, say you have the limit as x approaches 0 of 1 over x. What do you think this would be? So we can't directly plug in 0. So let's say we plug in a value close to 0. So let's say we plug in limit as x approaches 0. We can plug in values close to 0 from two sides. We can plug in something like negative 0.1, or we can plug in 0.1, because they're both close to 0. Suppose we plug in a value from the right side, so 0.1 on the right side of the number line. Basically, if this is 0, positive side and negative side. So we're plugging in a value from the right side. So if we plug in a value from the right side, so like 0.1, so 1 over 0.1 is just equal to 10. So suppose we plug in an even closer value. Suppose we plug in 0.001. This would be equal to 1000, I think. Yeah. So you can see, as we plug in values closer to 0 from the right side, this value keeps on increasing, the function's value. So if you plug in something like 0.00000, how many ever ones, we'll get an extremely high value. So we can clearly tell, as this x is approaching 0, this value is approaching infinity as it keeps on increasing. Therefore we can say the limit as x approaches 0 from the right hand side of 1 over x equal to infinity, or we can say positive infinity. What would happen if you plug in values from the left hand side, or basically negative values? So you have negative, say, 0.01. This equals to negative 100. So what do you think would occur from the left side? It would be the same thing, right? Because you're plugging in values closer to 0, but just from the left hand of the negative side. So you would get, so this value would basically just approach negative infinity. So you can tell the limit as x approaches 0 from the left hand side equals to negative infinity, and the limit as x approaches 0 from the right hand side equals to positive infinity. So since both of these values are different, so one is negative and one is positive, we can say that the limit as x approaches 0 from either side of 1 over x basically does not exist. It does not exist because these both values are different. We can say the limit does not exist. And that's basically the basic concept behind infinite limits. Alright, start with some questions now. Okay, our first one is the limit as x approaches, as x approaches 4 of, say, root x minus 2 over x minus 4. What would this be? Alright, since we have a root in the numerator basically, or in the fraction, we have to rationalize, or we have to find the conjugate of the side which has the root. So what would be the conjugate of root x minus 2 is root x plus 2, and we have to divide that by both sides. So on top we can, oh, that's my bad. One second. Yeah, I think I turned on some setting. Yeah, I think I, alright. So yeah, this is 4. So you can multiply by the conjugate on both sides. The conjugate of root x minus 2 is root x plus 2. So on top you can use the algebraic identity a minus b times a plus b equal to a square minus b square. Oh wait. So over here we would get a is x, root x, and b is 2. So root x squared is just x, and negative 2, and so it's minus 2 square, which is 4. Let me just rewrite this limit. And on bottom we have x minus 4 root x plus 2. We can cancel both of these x minus 4s, and all we're left with is the limit as x approaches 4 of 1 over root x plus 2, which equals to 1 over root x, which x is 4, so we can directly substitute now because we won't get a 0 or any undefined value in the denominator. So we'll have root 4 plus 2. Root 4 is 2 and 2 plus 2 is 4, so our final answer is 1 by 4, and that's it. Now say you have another question. Find the limit as x approaches 0 of the whole root x minus 2 minus root 2, that does not look like 2, divided by x. Over here too we can't use direct substitution, so let me just rewrite this a bit small. Since we can't use direct substitution, so we'll have to do the conjugate rule again because we have a root in the numerator. So the conjugate for this would be root of x minus 2 plus root 2 over the same thing. Alright, so if we consider this a and this b, we could use the a plus b identity again. So root x minus 2 whole square is just x minus 2, and root 2 squared is just 2, and obviously minus 2, so divided by this whole thing, x bracket root x minus 2 plus root 2. Now we can do 2 minus 2 obviously. Oh wait, this would be plus. Oh no, this would be minus. Now what are we gonna do? So minus 2 is minus 4, so this equals to x minus 4 divided by x times root x minus 2 plus root 2. What do you think we would do now? Alright, we can factor out, no, we can't factor. So if you, oh wait, hold on, I think oh wait, I did something wrong. This in the question, it's actually plus. Yeah, so it should be plus here too. So this should be x plus 2 minus 2. So plus 2 minus 2 cancel out, and yeah, plus 2 minus 2 cancel out. So all we're left with here is x divided by x times root x minus 2 plus root 2, and x cancel. So we're left with the limit as x approaches 0 of 1 divided by root x minus 2 plus root 2. Now we can plug in the values. 0 minus 2, so if you plug in root 0 minus 2, oh wait, this would be plus. Oh yes, oh yeah, that's my bad, because since we, yeah, so root 0 plus 2 is 2, so it's root 2 plus root 2, root 2 plus root 2, which is just 1 over 2 root 2. That's the answer. If you didn't understand the question, I'll just redo it quickly once. So we had, so the question basically was the limit as x approaches 0, whole root of x plus 2 minus root 2 divided by x. This was the original question. So you multiply with the conjugate. So this would be the limit as x approaches 0 of root x plus 2 minus root 2 and root x plus 2 plus root 2 over x times the same function. So a plus b, a minus b, so all we're left with on top would be, one second. So x plus 2 whole square is just x plus 2 minus 2 divided by this. So on top, minus 2 plus 2 cancel out. This equals to the limit as x approaches 0 of x divided by x and this function plus root 2. So x cancel, so all we're left with is this. So when you plug in x is 0, now we'll have 1 over root 0 plus 2 plus root 2, which equals to 1 over root 2 plus root 2, which equals to 1 over 2 root 2, and that's how you do this question. And that was my bad, actually. I copied the wrong question there. Alright, now what if you have a complex fraction in the numerator or denominator? So we have, suppose, 1 over x minus 1 over 3 whole divided by x minus 3. What would you do now? So in this case, you multiply both the numerator and denominator with the common denominator of the fractions. So multiply it by 3x on both top and bottom. So if you multiply it by 3x, so this times 3x, so this term, 3x times this term, the x would cancel and all you're left with is 3. So one second, as x approaches 3, all you're left with is 3 minus 3x times this term, the 3's would cancel and all left with is x over x minus 3 bracket 3x. Alright, now on top, if you look carefully, we can factor out a negative 1, and when you do that, all you're left with is x minus 3, because minus 1 times minus 3 is just 3, and minus 1 times x is minus x. 3 minus x, basically this is 3 minus x on top. Over we have x divided by x minus 3 times 3x. So we can cancel the x minus 3's. All we're left with is negative 1 over 3x. Now if you plug in the value of x, we'll have negative 1 over 3 times 3, which is negative 1 over 9, and that's it. That's your answer, basically. Now our next question is a trigonometric one. So you have the limit as x approaches 0 of sine 5x divided by x. What would you do? Alright, so this would be equal to, remember the law, sine x over x, limit as x approaches 0 of sine x over x is just 1. So we have a similar case over here if you see carefully. So all we need is a common numerator denominator x value. I'll show you what that means. So this would be the limit as x approaches 0 of sine 5x over x times, say, 5 over 5. If you do that, we can get this 5 here and keep this 5 the same. This would be equal to the limit as x approaches 0 of sine 5x over 5x times 5. Alright, so we can't use 5x over 5x directly as 1. So what would we do? We can say 5x equal to y. And since we have y in the equation now, we have to change the limit expression to this will be equal to the limit as y approaches 0 of sine y over y times 5. Now the limit as y approaches 0 of sine y over y is just 1 multiplied by 5, which is 5. So 5 is our final answer. Alright. Say you have the limit as x approaches 0 of sine of 2x over 5x. What would you do now? Okay, so if you multiply both the sides with okay, so this would be equal to the limit as x approaches 0. We need a value so that we can get 5x on top, and then we can get so this would be equal to sine of 2x over 5x multiplied by 5x over sine 2x multiplied by 2 over 5. So now we can change the terms in different places, or we can transpose them to other places. So I can rearrange this as the limit as x approaches 0 of sine 5x over 5x, because we brought 5x here, multiplied by 2x over sine 2x multiplied by 2 over 5. So we know that this equal to 1, this equal to 1. So what would we do now? Let's say 5x equal to y and 2x equal to g. So we can separate these limits. So this would be equal to the limit as y approaches 0 of sine y over y multiplied by the limit as g approaches 0 of g over sine g multiplied by 2 over 5. So this is just 1 and then 2 over 5. So the final answer is 2 over 5. Okay, and we'll be going towards our last question for today. So say you have the limit as x approaches 0 of sine 7x over sine 3x. So in one position we need sine 7x over 7x. So we need 7x down here. The one position we need 3x over sine 3x. So we need a 3x on top. And then we need 7 over 3. Because we can clearly see the answer is 7 over 3. So we can multiply this by sine of 3x over 7x times 7 over 3. Yeah. So what would we do now? Actually, you can't. This would be a more unethical way of approaching it. Let's say you can multiply it by 7 over 7 times 3 over 3 times x over x. This is better. So when I rearrange the terms in the numerator and denominator, I can get sine 7x over 7x, and then I can get 3x over sine 3x. Then because I took this term and this term, I also took this term and this term, so all I'm left with is a 7 and a 3. So times 7 over 3. Alright, so we know this is 1, but we have to justify it. So we're gonna say let 7x equal to y and let 3x equal to g. So this would be equal to the limit as y approaches 0 of of sine y over y times the limit as g approaches 0 of g over sine g times 7 over 3. Alright, so we know our final answer is just 1 times 7 over 3, which equals to 7 divided by 3, and that's your answer.